You are now listening to In the Trench.
Welcome back to another episode of In the Trench. Today, I forgot my beanie. Today we have Dr. Christopher Ferrie. He is an author, and I have one of his books here, Where Did the Universe Come From and Other Cosmic Questions. We talked about a lot, anywhere from time travel to simulation theory to the possibility of extraterrestrials, possibility of intergalactic travel. Trying to think what else. We really talked about a lot. So I'm going to make this intro very short. Thank you guys so much for watching all these episodes and keeping up the support. We really appreciate it. Everything you guys have been sending in, commenting, just all the all-around support. And we really appreciate if you guys were to subscribe, comment, like, and anything else we need to ask for, Nicole? Yes, your support. Oh, I can't end this intro without saying, stay tuned. Okay. Sorry. Watch the episode.
How's it going?
Good, man. Good. Thanks so much for coming on the podcast.
Yeah, no worries.
It was actually really funny how I came across your page, your book, all that stuff.
Stay tuned for season 3 of In the Trench.
Doing this podcast for a little bit now, so you know a little bit of the background of like In the Trench. And I'm a huge science nerd. Like I love space. I love. I've never dove in deep into quantum physics because I feel like it's way too complicated for me to even get started with. but I've always wanted to learn more about like time travel, the possibility of time travel, like warps, time warps, just everything about space. So I went to a local library and I looked for books on it and I found yours and I'm like, you know what? Let me hit this guy up, see what happens. Hopefully he could teach me. And then little do I know, you're an award-winning physicist out of Sydney.
Yeah.
So
I mean, yeah, there's lots of physicists. I'm just a regular physicist, to be honest.
well, no, I wouldn't say you're a regular physicist. You're like the most prominent children's book physicist.
Yeah, well, that's not something that many academics do. That's right. Yeah. So
super interesting. I mean, that's something I honestly found out about that recently. I'll just show you now. Made sure to pick it up.
Nice.
Where did the universe come from and other cosmic questions. So realistically, I'm super interested in hearing your take on your outlook. I'm like a quarter of the way through the book so far.
Right. Yeah, I mean the book is it jumps all around, kind of going through the history of the universe as we understand it. And I wrote it with a cosmologist. So Grant Lewis is the co-author in the book. So he talks about, what we observe when we look out into the universe through our telescopes. And then I talk about the quantum physics behind how we understand those things that we see out there. So like simplest example you can think of is, you see stars, right? Okay, well, what are those? What are those made of, right? And because we understand quantum physics, that atoms and molecules have these discrete energy levels, that we can actually see that in the stars, and then see that those fingerprints are the same for all of the stars. And so we know that all of those stars are made of the same stuff. And then when we look at our own sun, we see that the light from that has the same structure. And so that now we know that all of those stars out there are just other suns, right? So that's kind of like the structure of the book, about like these questions that plague scientists in the past and still plague scientists today, and how we have to bring all of this physics from cosmology, general relativity, Einstein stuff, all the way down to quantum physics to understand what's going on out there.
That's crazy. That's super interesting when it comes to. I've heard obviously that before in school, that the stars that we see at night, they're long dead suns that exploded and we're just now getting the light. Something I don't understand that maybe you can help me figure out a little bit is, this is, first of all, let me clear the air. I am not a flat earther. I just, I just,
Yeah.
there's a point that has been made that is interesting to me. That how come if the earth is spinning, right?
Mhm.
And then every day it's spinning and it's spinning on an axis, and that axis is spinning around the sun.
Yeah.
How come every single night we see the stars in the exact same place?
Yeah, it's a good question. I mean, they're far away, right? Like, so they actually move. So if you like, I don't know, you can look up like long exposure photos or whatever, and you'll see like the stars trace out circles, right?
Yeah.
So that's the rotation that you can see, the rotation of the earth, right? By just noticing that you get these concentric circles of everything that's out there in the night sky. But yeah, once the earth comes around to the same spot the next year, that star's in the same place. It's not exactly in the same place, like it's subtle, but it looks like it's in the same place just because they're so far away, right?
So what you're saying is that the night sky is almost like an image, and that image it's stuck there because we're getting the light from so far away that even when we're spinning, that image is still like rendering almost in our sky.
Yeah. I mean, that's good. I mean, there's definitely examples where you can see the stars move. I mean, you need special, you need really good telescopes, right? And maybe even special equipment. But yeah, you can see like at the center of our galaxy, astronomers can see stars going around the black hole at the center of our galaxy. But you need like 10 years of data to see it actually go around once.
Yeah, that picture, the first official picture of a black hole, was like a pretty outstanding breakthrough in science, wasn't it?
Yeah, it's incredible. I mean, it's awesome.
I hate that it was blurry. The first thing, something else I really don't comprehend is how we still can't travel. I mean, we could probably get to Mars if we wanted to right now, but how we still can't travel interplanetary, outside the Milky Way. How do we get the Hubble telescope out there? How did it manage to take pictures like of the black hole, of the Milky Way, of other galaxies? How we managed to do those things?
Yeah, I mean, to be honest, like the universe hates us, man. Like it's a miracle that we're able to be here and be alive. I mean, we haven't been alive very long in this scale of the universe. I mean, any minute some asteroid could come and just obliterate us. But so there's just some things that we'll just never be able to do. Like we'll never travel outside of the solar system.
You don't think in human history it'll ever happen?
No.
Really?
I mean, like there'd be no. Yeah, I mean, any sort of human that you could imagine, it would just never make sense, right? Because you wouldn't be alive to see it anyway, right? So if you traveled to the nearest star, I mean, that's several generations. I mean, you'd be on you'd have to have children on the voyage, and they would have to have children because the human lifespan isn't long enough.
And
so why would you do it, right?
Yeah, really, you just have to really love cultural advancement instead of personal advancement to do something like that. Because if you would ever be like, okay, I will never get to see what the ultimate goal is, my kids will never get to see what the ultimate goal is, and my kids' kids will never get to see what the ultimate goal is, but hopefully someday down the generational line somebody will. I don't see where it's worth giving my life up for that, doing something. But maybe in the future, this is very like, you know what Black Mirror is?
I've seen it. Yeah.
This is a very Black Mirror-ish take to this, but maybe in the future, the same way we can get the Hubble telescope so far out there, we'll send genetically modified embryos already with like all the teachings they need, that'll somehow get to the end frozen, and then when they're getting, let's say 18 years before the trip is over, they'll start developing. I don't know, maybe that's a way.
Well, I mean, there's an idea. It's called the von Neumann probe. So it's named after this guy, famous 20th century physicist John von Neumann. And it's basically a machine that goes out and has instructions for how to build itself. Goes out, uses resources on some planet, builds copies of itself, and then they get sent out, right? And if it builds 2 copies of itself that get sent out, then every time it visits a planet, it doubles, right? So eventually, these probes will just be everywhere in the universe. So I think if humans do something that is on some universal scale, it'll be with machines, not people. So
with machines with like some sort of human consciousness integrated?
No, I mean,
just straight up robots.
I mean, there's people that think that everything has some level of consciousness, like even a rock. So it's not consciousness as we know it, but it maybe the behavior might make it seem like it's alive or has thoughts or something, but yeah, it'll just have that one purpose, right?
So
go
then,
make copies of itself.
So you genuinely don't believe human race will ever get outside the solar system. So what's your opinion on Mars? Because that's something that we're genuinely starting to try to populate Mars.
Yeah, I mean, I don't possibly will visit. I mean, we visited the moon, but yeah, that was just for shits. We might go put a human on Mars, but it'll be a long time before, say, we populate it. I mean, there's places on Earth that we can barely manage to survive, right? I mean,
I've always
Antarctica, the bottom. We hardly have explored the bottom of the ocean. So yeah, there's lots to explore here on Earth. You do want to go and you see what's out there. There's just like this insatiable curiosity, but I don't think I won't see it in my lifetime that there'll be people living on Mars.
I wouldn't be so sure about that because I know for a fact Elon is trying to get a civilization started, but there's already been like a group of people selected as the first generation of people to move to Mars. It's a one-way trip to Mars, and I believe it's like 30 or 40 people that got selected. And it's funny because one of my ex-coworkers, he was a very depressing human being. He's like, nobody loves me, none of this. So I signed up because no one's gonna miss me. And I was like, damn, that's the saddest thing ever. But
yeah, well, those I mean, I think if it's like, I know of one actually, and I know one of the scientists that was selected actually went to grad school with them.
He got selected to go to Mars.
I don't remember. There's at Mars One, or I don't remember. There was this thing, right, where like I think it may be the same thing you're talking about.
Yeah.
But it was like, in a sense, it was like a gimmick, right? I mean, it was like some company that said they're going to do it, and it's it's not going to happen, basically.
Oh, okay.
So yeah, I mean, it's there. There's a lot to overcome. Like going to Mars, going to the moon, is that it actually happened is just mind-boggling how much stuff had to go right to make it happen.
Does it annoy you the amount of people that still believed the moon landing was fake?
I don't know.
What are your opinion on those idiots that with those skeptics?
Yeah, I don't know. Like it's hard. It's hard. Like if you go and talk to people and watch what they watch and have a kind of understanding of their life, it's not hard to see why they believe these things. Like they're part of a community. There's a great documentary. It's called Behind the Curve. It's on Netflix.
I think I saw that one.
Yeah. And so you look at these people and you think maybe they don't actually believe it, but it doesn't matter, right? They're part of a community. They're accepted in this community, and it's like leaving a religion, right? It's
It's a cult. I believe it's a straight up. It's like a cult because they go to those conventions and then, in my opinion, it's mostly brainwashed. But then also you see the type of people who go to these things, and there's definitely like a certain type of class of people that go to those conventions and claim we're in some dome where there's water above us. The sun
Australia
is
doesn't even exist, right?
Australia
I'm
doesn't
an
exist.
actor.
You're what's it called, a crisis actor?
Yeah.
Yeah,
Yeah.
no, it's I get frustrated, but at the same time, like I love that those people exist because it's content for me. Like I sometimes sit down and watch those videos just to get a laugh, but it's like the amount of absurd things they say.
Yeah, I mean, we're not that impressive, right? In the end, I mean, it wasn't even 100 years ago where, if two physicists got into an argument, they just duel and one of them would shoot the other one. So, we're like slightly evolved, apes. And I mean, it's a real, we're on like, we're basically just always on the like this precipice of utter chaos. So though society is pretty fragile. It only works because enough people agree that it's a good idea, right?
Yeah.
But most of it's fictitious, right? Economies, culture, it's all just some made up story that we choose to believe.
So much smaller in the grand scheme of things when you think about it. Like I've seen those videos where it's like it's a person and then it zooms out and then it's a car, zooms out it's Earth, zooms out it's the sun, then it's Antares, and then the other suns, the other stars that make our sun look like a grain of rice. And it's just like we are literally cells. Like we are cells. Like it's what it makes me feel like. But speaking of culture and all stuff, let me kind of, what's your opinion on extraterrestrial life?
There could be life on other planets.
Like intelligent life.
It's possible, but the distance between stars is enormous, right? Like just even in our own galaxy, if some culture, some organisms evolved and developed intelligence and were able to like send out signals or possibly even do some sort of interstellar travel, I mean, they'd be long dead by now, right? Like if it evolved like so, it's hard to imagine the distances between stars and galaxies, but when you think about like just how long it takes life to evolve and how much effort would go into doing something like interstellar travel, and like how frequently just disasters happen,
It just wouldn't be worth their time to even attempt it.
yeah, I mean, we think about it, right? We think about going to other stars,
So you
visiting
genuinely
other
don't
solar
believe,
systems.
you don't believe at all that there's ever been a sort of encounter they've ever visited? Nothing.
No.
Okay.
No, like think about what would we do, like if we say we found life on another planet, and then maybe not even intelligent life. We go on one of the moons of Jupiter. We show up there and
space cows.
Yeah.
I think we kill them. Human nature is to destroy.
Yeah.
So
can you kill it? Can you fuck it? Can you eat it?
That's what we do. It's horrible. I completely agree.
Yeah.
I'd like to believe that we would leave it alone, study from afar, figure it out, maybe.
But the risks involved, right? Like you would,
out of it.
Yeah, you would quarantine it. You would, no. I mean, it'd be terrible. It'd be terrible
for them.
Yeah. So if there was something, something that was sufficiently more advanced than us, then the same thing would be true.
So
And we
I mean,
would know, like there's like this progress, right? There's like
yeah,
slow progress of we're sending signals out, right? So we sent a probe, it went beyond the solar system, but we're constantly just sending out information. All of our broadcasts are,
we're receiving signals too.
Twitter feeds and things, right? Are going out there, and so there would be evidence
Yeah,
beforehand that there's something happening on Earth, and it's getting more and more complex.
yeah.
It wouldn't just all of a sudden be show up with giant spaceships and
Take
ready
over.
to have a war.
I mean, that war would be over in a second. I don't believe if, like, again, if they can't even get to us, and they're hostile, I don't think we stand a chance. Like, they have the technology to travel light years. How are we gonna do anything with lead balls that get propelled with mini explosions?
Yeah. Well, I mean, we could be part of we could just be a petri dish for some other, for some other, or just a simulation.
That's probably the scariest outlook I've seen. Like, to think that we're in a simulation scares me, like, deeply, because how does that make sense? Because I look at myself, I'm real, you're real, my girlfriend next to me is real, I'm touching her, and it's like, to think that maybe one day you die and you wake up in some intergalactic mall, like, damn, that was a good VR experience. Like that.
Well, it's kind of like the Sims video game, right? Like,
Yeah.
you have your little characters, and they play out their little lives according to some rules. And maybe in the Sims at some point, I haven't actually played it
I've
since
never
like the
played
first
this.
one in
Yeah.
like 30 years ago, whatever. But maybe at some point the game gets complicated enough that the Sims in the game play Sims and create their own Sims, right? And so you think the odds are against it. The odds are for it. I actually like that we are some simulation, right? Because as soon as we're able to simulate consciousness, then we will, and we'll do it like on a massive scale, right?
Tesla
And
bot.
yeah, and then those things will then simulate other things, right? And you get like this like regression, and what are the odds that you're at the top of that chain, right? Pretty low.
Yeah. Damn. There goes my sleep for the night.
But the thing is, like, why would you act it? If you could prove to me that I'm in a simulation, I wouldn't act any different. I wouldn't do anything. Like, if the things around me aren't real, the other people around me aren't real, it's still the case that there's rules built in, so that if I kill one of them, the rest of them are going to put me in jail, right? Like, so I wouldn't behave any differently if you could even prove that all the people around me weren't real, because there's
That's
still
true.
rules, right?
Yeah.
And this is some experience I'm having, and I'm going to do what I need to do to enjoy it.
That's a positive outlook into that, I guess. Still super scary. The thing we're in a video game is, I would find a way to hack it. Maybe some superpowers or something. If they were in a simulation, I need to be that one guy flying around. Let me ask you about, okay, so you're saying we won't ever travel great distances. How would you travel great distances? Would the only way be like to bend space?
I don't think that would be possible. Like, you just wouldn't be able to generate enough energy.
Okay.
Right. So all the energy that we have is from the sun.
Mhm.
So the sun doesn't warp space enough to create some sort of new structure that we've never seen or aren't aware of.
Yeah.
So how could we take a portion of that energy and do it? And so the amount of energy that we can generate limits the the speed that we can travel, and it's just not fast enough.
No.
I mean, we have, there's ideas, there's proposals for how to do it, but yeah, I mean, some of them are semi-realistic, but again, like, if you look at the details, it's not as spectacular as people want to believe it is.
Yeah. Have you heard, I mean, I have to say this, but have you heard of element 115, 115?
It rings a bell. What is
So,
it?
I'm going to tell you what you're going to think is a fantasy story. And it maybe is, but there's a guy by the name of Bob Lazar. I don't know if you ever heard of him.
This all rings a bell. Maybe I
Yeah.
heard about it at some point.
So Bob Lazar was a propulsion guy. Like that's what he studied. He attached a rocket engine to a Honda Civic in the 80s. And he lived in, I want to say, New Mexico. And he essentially was doing all these crazy propulsion experiments. And I mean, this part's real because it's like documented, all this. And he got contacted by this agency called Los Alamos Labs to work on a secret government project. And the way he described it was that they took him to this place called S4, which is a site 15 miles west of Area 51. And they had him work on a UFO. He said they say that he said there was 9 of them, that the one he had to work with, he was working with a buddy, and there was about 15 groups of different scientists, but they would never talk to each other. You can interact. And it was just him and his buddy, and they each had different purposes, these scientists, and their purpose was to figure out how this UFO maneuvered. And he essentially came to the conclusion that it was some sort of gravity manipulation device, gravity propulsion device. And he draws it, all that stuff, and he describes it as when it flies, because they got it to fly. They were doing the story. They got it to fly, and they were moving it left, right, up, down, diagonal, all these things. And it doesn't obey the laws of physics when it comes to friction or propulsion, for that matter. So when you have an airplane, if you want it to turn, it's to take a really long turn. With this, it's like when you have a laser pointer and you're pointing it at a wall, and you can just move it as fast as you want. That's how they were describing this. And they're describing it when you're inside of the UFO, that there was, you wouldn't feel like if it stopped, you wouldn't inch forward, you somehow, whatever. He came to the conclusion that it was a new element called element 115 that wasn't in the periodic table back then. So the reason we even know about this story at all is because he started taking his friends out there, because he started getting tired of all the secrecy. So he started taking his friends out to go at night, because he had the test flight schedules. He would take his friends to go watch it at night, and he even recorded it. There's tapes, and there's also a Netflix documentary that's called Bob Lazar UFOs or something like that, but you can look it up. And all this that I'm saying is on there. And there's the footage of him with his friends at night, but all you see, it's the 80s. It's a really really bad camera, and you see a light, an orb, move in crazy directions, but it could be anything.
Mm-hmm.
And he did it with his friends so often that he got caught eventually. And when he got caught, they let him go, and he got so scared they were going to kill him that he went straight to the press and said, if I get this out there, they can't kill me, because then it'll look super suspect if they kill me. So he just went to George Knapp, which was a reporter back in the day, and it went viral. He told his story. Everybody's calling him crazy. They're calling him that he's telling the truth. All this. The only interesting part of his story is that, for one, his story never changed since the 80s. And two, a lot of the things that he said that people said it was fake have come to be true in said time. So he talked about element 115. Element 115 was added to the periodic table in 2004 because they were able to make a certain isotope in Germany, but it dissipated after 4 nanoseconds, but they were able to have it there. And he was explaining that every element has different isotopes that are stable and unstable, and that element 115 is no different, and that if there is a stable version of it, that's what creates that propulsion, that it manipulates gravity. So he was right about element 115 and its properties, and then he was told in Los Alamos they asked him how he used to like check in, and there's a machine that would measure, because they didn't have fingerprints back then. It would measure the bone length in his finger, and that's how they would identify him. And everyone's like, "You're stupid. That's crazy." That machine came up 2007 as true, and that's what they used to use in CIA days, like back in the 80s. So a lot of his stuff, I just told you the whole spiel. It goes a little bit more in depth in the documentary, but it makes you think. Like it does make you think a little bit.
Well, we don't. Like history is full of people that say, we have everything figured out, and all there's left to do is, more precise measurements, and then some revolution happens, right? So, but the thing is, every revolution is consistent in some way with the previous paradigm, right? So Einstein came up, with his theory of relativity, but it wasn't like all of a sudden Newton's theories were completely useless. It was just a small correction to what Newton had figured out. So, and the same is true of quantum physics, right? I mean, it's still consistent with what we knew before. So the idea that like one of the elements in the periodic table is somehow like going to completely rewrite the laws of physics, it doesn't, like, it's implausible. It's just not something that has ever happened in the history of science. And I think if you thought about all the possible ways that it could happen, it just wouldn't make sense, because we would have noticed it long ago, right? So to create these elements, you need a massive amount of energy, and where is this energy coming from, right? If you think that you can just do it in your backyard, right? Like if you think about the massive amount of engineering that has to happen to create these particle accelerators, it's just, the idea that someone's going to do it in their backyard it just doesn't make any sense.
Does it scare you what they're doing in CERN?
No.
I'm scared. I'm worried about CERN.
Like the idea that they're going to create like a mini black hole or something.
I mean, they're speeding up atoms or photons to 99.9% the speed of light, and then having them crash into each other.
Well, okay, so so this happens all the time, right? In the atmosphere. There's cosmic rays that have way more energy than what we can generate at CERN. And so if something was going to happen, it would have already happened, right?
Okay, yeah.
So the kinds of particles that the energies in the particles that they're generating at CERN, it's the same thing that happens in the atmosphere all the time, but in a more controlled environment, so we can study it.
Yeah. CERN, yeah, great.
Yeah, no, like it's
proud,
funny, like when you like study this stuff, it's like you kind of like I watch science fiction. I like watching science fiction,
of course.
But it's and I'm not the kind of person that's like, oh, that's incorrect and that would never happen, because it's just so so far off, of course, that you just have to say, okay, I'm going to suspend belief for an hour, get my entertainment, and then go back to the real world, right? So the kinds of stuff that people talk about, that end up, on tech blogs and all of Elon Musk's fans like to think about. It's like Hollywood, right? I mean, that's it. It's too far removed from reality.
Of course. So
I've been to Los Alamos.
Oh, Los Alamos.
I lived in New Mexico for a few years.
Really?
And So they do public research there, and there's people that work there that don't have top secret clearance, and so as a non-American, I could go and visit, and you drive by, and there's like experimental stuff happening that you're not really supposed to look at, and X division and all that, but it's all just like advanced engineering stuff. There are things that probably are beyond our imagination happening, but it's not that far. It's not like wild stuff, right? So an example, like a good example, is adaptive optics. So adaptive optics is like when you think about a telescope, it has like glass, right, that form a lens, just like my glasses or microscope or whatever, but it's fixed, like the shape doesn't change. And if you look out into the sky, you can see like stars twinkle, right? And the reason that they twinkle is because there's like turbulence in the atmosphere, and that's a big problem if you want to study stars, right? So the early pictures of galaxies and things, they're just terrible. It's just like fuzzy stuff. And there's this story, I don't even remember who told me, where nowadays you have adaptive optics. So you have like a kind of like a liquid crystal that replaces the lens. Yeah. So it basically measures the turbulence in the atmosphere and then corrects for it really quickly. And people in the military developed this technology, and they would go to scientific conferences and watch astronomers put up these photos and just sit in the back and giggle at how primitive it was, right? And then they had this technology, and then when it was finally declassified, it completely revolutionized astronomy. But the government sat on it because it was, they considered it top secret. They sat on it for who knows how many years, right? So that's the kind of thing that what is probably happening all the time, right? It's not, and it's not like some wild, crazy thing. It's just some engineering feat that they were able to achieve that provides some better technology.
It makes you think what else they're sitting on right now, because if they were
the one thing that's relevant to me is my research is quantum computing, right? So there's a global sort of effort to build a quantum computer. Most of the tech nowadays, there's companies involved like Google and IBM who have a lot of trade secrets that they don't reveal. But for the most part, a lot of the stuff is like public. Scientists publish their findings and their research, and even like Google and IBM and the big players, they publish a lot of stuff out there. It's like details, like secret sauce, kind of like how they manufacture them that they don't reveal. But the rest of it's public. But it may be the case that some government somewhere has already built one, and they're just not doing anything about it. It's kind of like, have you ever heard the story of Alan Turing and the cracking the Enigma code?
I saw the movie.
Yeah. So he cracked it, but the thing is, you can't reveal that you've cracked the enemy's code, right?
Of course not.
So because then they would stop using it. So they couldn't action every piece of information that they decrypted, because then the Germans would have figured out right away that they did it. So that's probably happening. There's probably instances of maybe even transformative technology that a government or company or someone has figured out, but they can't use it. They can't reveal that they have it.
And it's nuts that the reason this is all a thing is because of war and power, and you don't want to give up power to another country. And I feel in a way having all these, I'm not a pro one world order. I feel like that would be super destructive. But it's horrible that since there's so much war and division between these countries that we're so held back technologically. But because if we all work together, just imagine where we'd be as a society right now. I was reading a book a couple months ago about how we are 1,000 years behind where we should be because of religion, for example. For 1,000 years, and if you were interested in science or any STEM at all, you were labeled a witch or a demon or whatever, possessed. So they would, if you look at the stars or you come up with a theory about something, they'll just burn you at the stake. So that happened over 1,000 years because of religion. So you'd imagine if that stupidity never happened, where we'd be at the moment.
Well, I mean, probably 1,000 years from now, people will say the same thing about us. Like we're just absorbed by, consumerism and whatever's on our TikTok feeds. So it's no different. I think that I don't know. I mean, you need some sort of competition to drive progress, right? If
Yeah.
there's no if there's no competition, then things will just stagnate.
I see.
Right?
I see. I agree with that.
So maybe there's a way to simulate competition or find some new, some new challenge where people can compete in a friendly way rather than for resources or power. But that has to be there, otherwise things will just stagnate.
Yeah. Let me ask you about you now. We've been talking a lot about crazy theories and other stuff. Let me ask you about your Australian Research Council Discovery Early Career Research Award.
Oh yeah. So that's a like an award that you get after you finish your PhD.
Okay.
So yeah, long story short, I was some kid from some farming town in Canada. No one in my family even finished high school. And I got in with a good group of friends. They said, you can go to the university and you don't have to get a job. And I said, that sounds great. So I followed them to uni and just constantly avoided getting a real job, staying in school as long as I could. And eventually they kick you out. You get the highest degree you can get, a PhD, and then there's no more school. You can't keep going to school. I'd keep going if I could. And then there's a gap between a PhD and becoming a professor, right? So professors are typically older, and you need more experience than just like this schooling. So you usually spend, depending on the field, 3 to 5, maybe even 8 years or so doing research only for professors. And then you're ready to apply for a job at a university, like a permanent job at a university. So in that space, there's all sorts of awards. Like the National Science Foundation in the US has awards. The Australian Research Council has these awards. This one's, they have these they always have these funny names with acronyms, but this one was called the DECRA, the Discovery Early Career Researcher Award. So that was like this space between when I finished my schooling and now I work at a university, and I could take that funding and then do my own research to prove later on that I'm capable of being a professor.
So
it's a pretty good, you
Yeah.
get the salaries in academia in Australia are pretty decent compared to the US. Like with these awards in the US would be like, maybe you get like a $50,000 to $60,000 salary, something like that. Which it's pretty decent. It's probably a quite a bit above the median salary in the US. In Australia, the things are things are a bit more expensive. Like everything's more expensive in Australia, but those grants were like around 100,000 a year you'd get, and then you'd get funding for your research on top of that. So it's pretty generous, sets you up to, really be able to do good research and then prove that you can hack it as a professor.
So you moved to Australia from Canada for that reason, essentially, for the
yeah, kind of. Like, so
Okay.
I moved from Canada to the US and did another one of these. I had some award where I lived in New Mexico, worked at the University of New Mexico for 2 years, and then from there went to Australia. So it's just kind of like you follow where the opportunities are and where the jobs are, and also where the people who do research that's similar to yours is. So there's a big research group in New Mexico that does this, and then there's one in Sydney, happened to just be one of the spots in the world where there was a lot of research in the field that I was studying.
So let me ask you what your end goal is. So like if you could accomplish one thing and that's the last thing you accomplish, what would it be?
Oh shit.
This guy.
I don't think about goals, to be honest. Like
Okay.
I just the problem with goals is that you reach them and then you have to come up with a new
A
one,
new one. Yeah.
right? So I just like to, just whatever I think is cool, make cool shit and die eventually.
That's my goal. Hopefully
Yeah.
this stays longer than I'm alive. But I do have one last question. Do you believe in the possibility of time travel?
Time travel. I mean, we're traveling through time right now, right?
Yeah.
So
Backwards. Or forward. Because I know there is a way to time travel technically, but the only way you do it, you'd have to move faster than the speed of light, or at
yeah,
least at the speed of light.
so the yeah, time, it's hard to think about because time's a relative concept, right? So if you heard like the twin paradox, right, where I actually have a twin brother, so we can say I take off on a rocket ship, travel close to the speed of light to the nearest star, come back, and for me, because it's only 4 light years away, the whole round trip was 8 hours. So I look like I've aged 8 hours, but for you on Earth, many years has passed,
Yeah.
right? So have I traveled through time in that scenario, right? Some people would say yes. The idea that you can go back and change events in the past, that's not possible, right?
You don't think it is?
Yeah. I mean, well, look, there's the most sensible way to think about it is the way the Back to the Future scenario is not possible, right?
Yeah.
Where you travel and you do something in the past and that changes the present. But if you subscribe to like this kind of multiverse, many worlds sort of thing, then what happens is if you could travel to the past, right, then you're on a different sort of timeline, in a sense, right?
That's what I heard.
So your old present is just something that you never have access to anymore, because everything in your future is on a separate timeline. So that you can make consistent, right? That doesn't run up against any logical contradictions. And the other way to do it would be what's called a closed time-like curve. So if there's just a loop that never generates, so in this scenario where you travel back to the past and then you end up in your current present at some point, then when you get to that present, you have to travel back to the past. So it's a loop, right?
Yeah.
So you can't change something that's already happened.
You could relive it.
But yeah, you could potentially relive it.
So do you think you could see into the past?
I mean, we do. I mean, because light has a finite speed, we see past events, right?
Yeah.
And maybe maybe it could be the case that events that happen on Earth, we send out signals, right, and they somehow approach like some super massive black hole, and they get warped around and come back, and at some later time we can see Earth. We look out and we see Earth because the light has bent around some massive gravitational object. But yeah, I mean, that's possible, I guess. But it's all because light travels at a finite speed, and when you look out, you're seeing the past. You're always seeing the past. Even when I look at my hand, I'm seeing my hand as it was like picoseconds ago.
Yeah.
Right.
So no flux capacitors.
No flux capacitors, unfortunately.
Well, I gotta say again, I am really truly grateful for having you on, and I am going to plug this. Make sure to go get Where Did the Universe Come From and Other Cosmic Questions by Chris Ferrie and how do you say his name? Grant
Lewis.
Grant
Yep.
Lewis. I'm definitely gonna
Yeah.
finish that
Cheers.
book.